Good good afternoon, everyone. This is our research demonstration video. In this video, we will be demonstrating our research project. Basically, our research project will be analytic server project. It is a complete analytic server package. So it contains fraud analysis and protocol analysis and IoT analysis and performance analysis. Mainly in this industry, the enterprise level industry, they need more analytic than ever before. That's why we thought to implement analytics server. As I told, we have four major functions. I will be demonstrating about my function, that is fraud analysis and fraud detection and analysis function. It is basically contain two parts. One is for fraud detection and one is for fraud analysis. When we go to the dashboard, we can see the neural network and rule engine in the menu hierarchy. This will be my part. In the neural network module, it will be what it will be doing is it will create a fraud detection model. It can inspect incoming data traffic, and give the traffic status. What is it, if it is a fraud or not a fraud. Here you can see we have a trained model for the data set. For this demonstration purposes, I have used KDD dataset. It is a famous intrusion detection dataset. As you can see, once our module is trained, it has correctly classified this. Actually, this 0 means the normal frauds, and the 1 means the abnormal frauds. That means frauds. Zeros are normal. So you can see 43 times 0 has classified correctly as 0. And the 4 times it is wrongly classified, and the 1 is classified correctly 150 times out of 150 times. So you can see the it has. You can see it has accuracy, high accuracy, 0.9797. And you can see if F1 score, actually this is very important because this is a intrusion detection problem. Therefore we have to thoroughly consider about the true positive rate and false positive rate. True positive rate and false positive rate. Therefore, we have generate ROC curve also. As when the button is clicked, generate ROC curve, you can see the related ROC curve of the this training model. So you can see this has best classification path. With this, we can conclude that neural network is in a good training mood, so it can be good to use for practical purposes. After the neural network trained, it will be exposed as a SOAP web service. Once actually these are the these are sample models we have created. So likewise, users can create more models for their separate tasks. So once one model is created, web service will be exposed to the third-party application. So so web service will be exposed. So this can be consumed by any third-party application to detect their fraud activities. So once the third-party application is connected to the web service, it will this neural model will inspect incoming traffic, incoming data traffic, and check for the common patterns, attack patterns, like it is trained from here. So actually, this is the basic process of neural network model. So as I told earlier, neural network will do whatever the detection part. So that means it will detect if it is a fraud or not. So actually, in real scenario, this if this detection is not enough, because sometimes uh, original users also uh, be detected as frauds. It's can be such scenarios can be happen. So uh, we have to thoroughly focus on why it is become a fraud. So actually, this is done by from rule engine. So it is based on the set of policies. So actually, this is a policy-based fraud detection. So in the rule engine, we can uh, detect. We can explain why it is become fraud. So once the neural network detected if it is a fraud, it will send neural network module to it will send that data traffic to rule engine. Uh, Rule engine will analyze that data traffic, and it is trained to set of policies. So it contain set of rules. Actually, policies mean the rules. So and it will compare with that rules and check whether if it is any violation. So I will show some demonstration here. So once the once the train model is clicked, you can see the trained algorithm, and these are the rules generated for that data set. So you can see it has four classes. So actually the same data set will be used for this as well. So for analytics server, we have, so for the neural network model, we have used the KDD dataset, and same dataset will be used for this as well. The only difference is in neural network model. On neural network model, in the class column, we are label normal classes as 0 and all the other classes as 1. That means all the other classes are 4 but different 4s. So all the others are defined as 1 and normal classes are 0. So from neural network, it will detect if it is a fraud or not. So once the detected, from here it will train for detect what is the attack type. It means the class type. So in here it will check for the class type based on these rules. So these rules can be increased by increasing the number of data set we train. So for this scenario, we have used 100 data set, 100 rows of data set, because we having a CPU cost to train. So it is not possible to us to train for a very large data set since we don't have a GPU cost. So we have to use 100 rows for this demonstration. So this is the front scenario of this is the front scenario of happening, and the back end of this also has now I will move on to the code, so it will be the back end. So in here we have used we have used Spring MVC for this implementation. So it is has MVC structure. It has controllers and modules and services. So all the backend logic will be on the services, and it will be called from controllers, and saving part will be done in the modules. So when the special parts will be packages will be there for neural network and the rule engine. So in rule engine we have this for detector class. It contain the logic of the neural network model. So in here we have used a recurrent neural network because there we have a reason to select recurrent neural network because recurrent neural network can learn real time because since it has this LSTM layer, learning short term memory layer. Because of that, it can keep the previous state of the data. So it can memorize things. So therefore, that behavior can apply for real-time learning. So it is not possible with other neural networks. So that's why we have selected recurrent neural network for this task. And before give the upload dataset to a neural network, we have do some several pre-processing tasks. So before actually we have used we have used KDD dataset for demonstration purpose. So KDD dataset has 49 attributes, that is a large attribute set. So we have to uh, uh, reduce that attribute set by using dimension reduce technique. So it will be done in the normalized dataset class. It is in the pre-processing package. So this contain all the normal pre-processing tasks. So here we here we done three major things before send data set to the neural network. One is data pre-processing. Sorry, one is dimension reduction. We will reduce that 49 attributes dataset for 10 attribute dataset because once the attribute set is increasing, the neural network complexity also increased. So that means the training time will be increased. So it will cause for performance. So therefore, we have to reduce the attributes to as much as possible. So we have reduced the 49 attributes for 10 attributes using dimension reduction technique. So in there we will be doing the outliers removal technique. So we will remove outlier attributes from the dataset, and we have keep only the important attributes only. So once the dimension is reduction, it will be sent to the it will be sent to the uh, string converter. That means all string values will be converted into the integers and numbers. So because uh, our neural network cannot handle string values, therefore we have to replace string values with numbers. So we will be labeling string values with numbers, and finally we will send the data set to the normalization process. So in normalization process, what we done is we will be take we will be convert our data set to a one range, because our in our data set there can be multiple range for every rows. So it is not good to have multiple ranges for training to a neural network, so it will decrease the accuracy. So that's why um, we use a normalization process to uh, normalize our data set to one range. So once the normalization process is done, we will be send that data set to train to neural network. So in the training process, then again we have used another technique. There we will be splitting data set to test data set and training data set, and we iterate that data set uh, through model for several times. So when we iterating, for each iteration we will be swapping the splitting percentage. In one splitting we have used 80 to 20, 80 for training and 20 for testing, and other iteration we will be using 20 for testing and 80 for training. Likewise, we will be uh, swapping and doing the training. So that is the technical part of the implementation part of the our model for detection model. So that is basically happening in the our neural network model. So that is the first function of our model. So now I will like to invite Shakti to now I will like to invite Shakti to conclude the presentation with the authentication analytic technique. Shakti.
Okay, Sunny, thank you. My part is about authentication protocol prediction. So I'll explain first about the authentication protocol. An authentication protocol is a type of computer communications protocol or cryptographic protocol specifically designed for transfer of authentication data between two entities. Uh, Generally, it allows authenticate connecting entities as well as authenticate itself to connecting the entities. So, authentication uh, authentication will be the first place where the user and the system will be interacting. So that is a most valuable impact in system and user in the business of the IT industry. So it should be in a proper manner uh, to gain the business advantages. So in here, it is basically about three types of authentication protocols, which is used to authenticate in websites or the devices. So here, uh, uh, I will explain about that three protocols. There are three protocols called SAML 2.0, OpenID Connect. So, SMAL 2.0 is Security Assertion Markup Language 2.0. Is a version of SML standard for exchanging authentication and authorization data between security domains. It is based on XML. Uh, these are single sign-on concept authentication protocols. So, if you get the characteristics of the SML or the special reasons to select SML can be considered as like those are XML based. So therefore, it can be used in any platform independent. technology. So there are XML encryptions, and also user can use security tokens. That is good advantages for the authentication, and it use cloud services, support for SOAP bindings and HTTP relay bindings, and there are many of advantages by using SAML. And OpenID is it's promoted by the non-profit OpenID Foundation. It allows users to be authenticated by cooperating sites uh, and third-party services. Actually, this will eliminate the need for the webmaster to provide their own ad hoc logins system. So user does not need to keep separate user login credentials to each site. Normally, by example, I can explain. It will be more clear about these authentication protocols. Now we have seen when the website, when we go to a new website, sometimes it requires the login to the site. So in that site, if we are going to create a new login credentials, it will be a hectic task for the user. So for this purpose, there will be these single sign-on authentication protocols come into the picture. So those even though those famous authentication protocol provide the uh, different types of good benefits, but for the according to the requirement of the organization, it will be differ. Sometimes one may not giving the maximum advantages for the organization, because there are many reasons, because organizations may have different kind of technologies, different kind of purposes, different kind of other connection with the third party applications or the services. So then we need to find out what will be suit to get the maximum, optimize the benefits for the organization. So even though for a one organization, just only we can use one authentication protocol. So for a, even though for a experienced people, they cannot get a decision to use what kind of protocol which will optimize the benefits of the organization. So that's the purpose what we are going to do by using the machine learning. So we have used machine learnings to predict what will be the authentication protocol based on the previous data. So it will be somewhat not somewhat, actually it will be gain more accurate prediction to select the most suitable authentication protocol, because it has many historical data than experience developer or a technical person. So by that data, it can um, uh, train the data and the predict what will be the most suitable. So uh, for this model, we need to find out the what will be the supportive facts that will be affect to the affect to this prediction. So in this data set, we have selected uh, some kind of facts which will be really affect to the prediction to predict whatever the most suitable authentication protocol. So these are the I I I have find out 12 facts to supportive facts to predict the model. So one is transport protocol type, which is HTTP or FTTP or SMTP. Then it should be we should be know known, is it XML based one or not? Is it JSON based or not? Then if the organization needs SOAP technology or the token encryption, if it is used uh, need attribute encryptions and customize the encryption. So sometimes the authentication they may need customize the encryption than the getting the static encryption types. So and also some websites may use APIs, some may not, and this is not only used for the web based and also can be used for the other IoT devices. So these facts must be considered when the protocol what to select the what is the most benefitable protocol. So those are the things, and to um, train the model, and pre-processing part is the important part here, to uh, the to ready the data set before the training is very important. So Asanta has explained what is the pre-processing part and normalizations and other things, um pre-processing part. So uh, now I am not going to explain again what is the pre-processing. It has normally has done the whitening part and uh, clearing null value, all cleansing part. So this will be the uh, interface that users is. Previously I mentioned what will be the what will happen over there in inside of the model. So when we go to protocol analytic tab, you can see this interface with the previously trained model. You can see the last train data sets, inputs, outputs, and the modification and things. And if you need to create a new model, uh, we can select this button, and you can fill the these fields: a model name, number of inputs, and number of outputs, and other things. And we can select the uh, file by choose the file like this. We can select, uh, then just need to generate the model. Okay. So after you can see this is a previously done model with the you can see the model name and other things. So after now I have used random forest algorithm for this classification. This is based on a classification model. We can use KNN, K means, SVM, like that algorithm, but we normally for classification, the random forest will be performing very well. So I have used random forest. Now we can see the test error as 0.27. It's like accuracy uh, around 73 uh, percentage. So this will be the summary. So I have used 12 trees for each attributes. Now you can see there are feature 8, 6. Those are my attributes. Then it will be compare for a tree. There will be uh, comparing all other attributes. So that's how the tree will be coming to the decision trees. And the for the random forest, I got the maximum prediction type for using 6 trees. Now we can see for all trees and the features. uh, comparisons. So that's how the tree is coming. Then user can use this model for any kind of third party app to predict the authentication protocol by according to their uh, need. So that's it from my end.
Yeah, and the other part will be done by the Hani and Sachit about the uh, performance analysis and the IoT analysis part. So now I invite the Hani to conclude the presentation.